Welcome to qnawire.
Hello, and today I'm going to be walking you through finding both the angular speed and angular acceleration of a swinging door given the equation we know for its angle at any time t. So from the problem, we are given this equation, theta equals 5 plus 10t plus 2t squared, where theta is in radians and t is in seconds. So that may be important later. It's always important to think about your units, but I just want to point that out. For this problem, it asks us to solve for the angle, the angular speed, and the angular acceleration at different times t. So we need to know the formula for the angular speed and angular acceleration to calculate those. So here I have the basic formulas where omega, or the angular speed, is the derivative of the theta, or angle of the door at any given time t. And then the angular acceleration is the derivative of the angular speed at any time t. So we're going to have to do some calculus in this problem to get our answers. So let's start solving for first the angular speed. Omega equals d theta dt, which equals, first we have to think 5. That's a constant, so it goes away when we take a derivative. 10t is going to turn into 10 when we take the derivative, because remember, you take the exponent, multiply it, and then you get rid of one of the exponent. So we'll get t to the 0, which would be 1. And then finally we get plus 2 times 2t for a final equation of 10 plus 4t equals omega. So that's our first equation we need to find through the derivative. Second equation for angular acceleration equals the derivative of the equation we just found, so that 10 plus 4t. So that's d omega dt. And that equals, again, this constant, it goes to 0. And then we take 1 times the coefficient, and then this t is going to go away. So this is going to end up being 4. So notice here in the acceleration, we just get a constant number, and that's consistent with what you've been learning in this chapter. You should be seeing a constant angular acceleration for the more easier problems. So it all makes sense for us right now. So let's start plugging in numbers. So it asks first for a certain time. It asks for time t equals 0. And it wants you to find each of these at time t equals 0. So it wants you to find theta, it wants you to find angular speed omega, and it wants you to find angular acceleration. So let's do that. Oops. Okay. So theta equals 5 plus 10 times 0 plus 2 times 0 squared equals 5.00 radians. Next, omega, we take this formula, plug stuff in, we get 10 plus 4 times 0, and then that equals 10 radians per second. And finally, with our angular acceleration, this one's easy because it's always a constant, so it's always going to be 4.00 radians per second squared. So there are our answers for time t equals 0. And then we're going to move on to our time t equals 3, which is going to be the same deal. You're going to plug them in just like we did before. So for t equals 3 seconds, you're going to get theta equals 5 plus 10 times 3 plus 2 times 3 squared. And the answer you end up getting when you plug that into your calculator is 53.0 radians. Omega, we're going to take 10 plus 4 times 3, and that equals 22.0 radians per second. And then finally, for alpha or angular acceleration, again, it is constant and it's going to be 4.00 radians per second squared. So that is how you find each of those values for those different times t.